All right. Exercise 7 from chapter 5. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the United States is 134. So we have a knowledge about the mean. 134 milligram per deciliter. Assume that the triglyceride levels of the population of the United States are normally distributed. So it's going to say that they are bell-shaped. Let me just bring this closer. Are normally distributed with a standard deviation of 35. That's sigma. You randomly select a person from the United States. What's the probability that the person triglyceride level is less than 80? So if we pick one person in the US at random, guys, what is the chance that this person triglyceride level is less than 80? Less than 80 means very good. So here's how you write it down. You write probability of X less than 80. When do you write Z, guys? Only when he uses Z scores, if he tell you probability of Z. But since now it's a raw data, he gives you a mean, which is not 0. He gives you a standard deviation, which is not 1. Then we don't have a Z, we have X. Less than 80. Okay, which is normal. You already put directions using the calculator, but let's do it together. So what would be the lower bound, guys? We need less than 80. So to the left of 80. 80 is here, to the left, this way.
Negative?
Negative a million. Then 80. Then the mean, which is, what did I say? 135, 134, sorry. Mean is 134. And then 35. Okay, let's put technology to use here. I mean, you don't have to sketch it, but you can sketch it if you want to just see a visual. So second and distribute, normal CDF, guys. Negative a million, it's already there. 80, 134, and then 35. So here is a chance. 0, let's do it to 4 decimal places. It will be 0.0614. This is the upper bound, and this is negative a million, lower bound. All right. Actually, guys, it will be safe. I mean, I got you used to putting negative here, that's fine. But it will be safe to put a 0 there. Do you guys understand why? Even if you put 0 here. And you should get the same answer. Try it and you'll get the same answer. Do you guys know why? Why 0 is good?
Because 0 is less than 80?
What is it?
0 is less than 80?
Yes, less than 80, but you couldn't put 10. 10 wouldn't work if you put 10 or 20 or 30. We have to go to the far extreme. We have to go to the far extreme. But in this case, 0 is the far extreme. Let me tell you why. Would you have you heard any cases where someone has a triglyceride in the negative? That's not possible. What's the lowest level of triglyceride can a person have is 0. So you can go below 0. And I don't think even there's anyone who have 0 only triglyceride fat in their bloodstream. It has to be a little bit something. That would be dangerous not to have any of this at all. So 0 will be safe. But you guys, if you understand how to use the negative a million on the lower bound and some in the million, etc., in the upper bound, that would be fine. You can always use that. Okay, so that is the answer to the question. All right, Next, let me explain to you what we're gonna do next, and that's gonna be a segue to section 5.3. Okay. Please pay attention to this. There's a normal curve. It's Z. So we have a 0 and 1 here. That's a 0. Okay, here's my question to you. Let's see if one of you can tell me what to do here. Okay, let me just do the one that I put in my hand out, and I'll tell you what we need. Okay. Here's what we have been doing so far, guys. I'll give you the Z, and all what I did last week and what I've done today, this morning. I give you Z, and then I'll tell you, find the area to the left of this Z, find the area to the right of this Z, find the area between two Z scores. And then you've been using the normal CDF feature, which is great. Now look what I'm gonna do. I'm gonna give you the area. So I'm gonna go backwards. I'm gonna give you the area to the left of the Z score, which is 0.3632, this area in red. And I'm gonna ask you to find the Z score. That's what we're gonna do. So it's a total opposite of what we have done so far. What we have done so far, you have the Z score, and then you'll be asked to find the area to the left, the area to the right, the area in between Z equals negative 2.1 and Z equals 1.5. You just put it in the normal CDF, put the lower bound, upper bound, mean, and standard deviation, and then you get the answer. Now it's different. We're giving you the probability answer, we're giving you the area, and we need to find the Z score. Can someone tell me, what do you think the Z? Is it going to be positive or negative?
Negative.
Negative. Why? Because it's to the left of what?
0.
Of 0. Definitely. But probably you cannot guess what this one is going to be. Does anyone have a guess what Z could be? Estimated value? Probably it's hard to guess. So let me show you guys how to do this, either using the table or the calculator, but I'm sure that you guys are going to end up using the calculator rather than using the table. So let me show you how we could have found. We at least agree that the Z must be negative. Well, since we agree the Z must be negative, I'm just going to show you the table with the negative values right here. Remember this area, guys, 0.3632. Now, guys, the way I showed you how to use the table, if you have the Z score, you look it up in the first column and the first row, and you find the area inside. We're going to do the total opposite. We're going to go in reverse order. We're going to look for the area inside, and then from the inside, we're going to go outside and find the Z score. So remember, the area is 0.3632, guys. Let's see if we can find it somewhere. 3632. I would say, guys, it's somewhere. There you go. Look, 3632. You see this number right there. So now, guys, you need to find the Z score. Okay, can you see, guys, the Z score? It's going to be negative 0.3. And then I need to read the number, you know, just right above this. So I got negative 0.3, and let me show you the other number. Can someone tell me what the other number, that 100th place? So this is a negative 0.3, and you guys can see there it's a 5. So Z is negative 0.35. And just to show you here, look, guys, we went inside the table, we looked up the first column, it's negative 0.3. Then we need one more digit next to 3. We looked it up in the first row, it's 5, and we put negative 0.35. Now I'm sure you guys would like to see how the calculator is used here. Okay, watch. So the area to the left of Z is 0.3632, and we need to find Z. You ready to see how easy it is to use the calculator? Watch. You go to second, distribute. We don't use normal CDF. Normal CDF is reserved to find the area, the probabilities. We need something that does the total opposite. Can you see it on the screen, guys? Is there any feature that speaks into this? Yes, the inverse norm. Very good. The inverse norm, guys, it says inverse. Inverse means reverse, you know the process. And this is normal. So this is inverse normal. I'm going to go take you to it. Okay. It asks for 3 things, guys. The area to the left of the target, the mean, and the standard deviation. Well, the area to the left of my target is 0.3632. Let me put it there. And since I'm using Z-score, I just leave this with 0.1 and then hit paste. And I need to get negative 0.35. Definitely I'm gonna get this answer. There you go, guys. If you round this to 2 decimal places, it's gonna be negative 0.35. So let me just say, using technology, using TI 84, Z will be equal inverse norm, area to the left, let me just write the direction, 0, 1. Always 0, 1 for Z, always. So 0.3632, 0, 1. And that will be negative 0.35. If you're using this calculator, let me show you. You should appreciate the calculator by now. You'll see you're gonna make a lot more use of it. So you just go to inverse norm. It doesn't give you area 0, 1 or mean standard deviation. You have to put them and separate them with a comma. So you put the area first, which is 0.3632, comma, 0, comma, 1, and close. And you guys don't be surprised. It's going to be the exact same answer. All right. What about?
Can I ask a question?
Yes.
So it's always going to be 2 digits?
Always. Z-score is always 2 digits.
Okay, thank you.
And if you ask me why, because the table is designed with 2 digits. So we'll just follow the table always. All right, let's do this, guys. We're going to do it on the calculator first. I'm going to give you you will see, I'm going to give you some applications later why we need to know this. And you're going to find it very interesting why we do those types of problems. Okay, I'm going to give you the area. Let's make it 0.271. That's the area, but it's not to the left, to the right. And I want you guys to help me find Z. And this is a Z line. Okay, here you go, guys. I'm going to get the calculator ready. Second, distribute, inverse norm. What do I put in there?
$0.271.
But remember, I said this area must be an area to the left of the target, not to the right. But by default on this formula,
0 and then the 1 for the mean.
so what do? In order to use
Oh,
this feature, the calculator doesn't want the area to the right of the target. It wants the area to the left of the target.
Would you put the negative number
No,
of
not
that
negative. What do you mean by negative? You mean if this is 0.271, guys, what would that be?
So wouldn't it be 1 minus?
Exactly. That will be 1 minus 0.271.
one? Okay.
Got it, guys? Does that make sense?
Oh,
This
so
is how
Yes.
the formula is built in. It's built in to ask for the area to the left, guys. So if the area to the right of given to you to find the area to the left is, you can do 1 minus. I'm going to show you a trick later. You can leave the area to the left and I'll show you how to figure out the answer, but just bear with me to do it properly now. Okay, and now 0 and 1. Watch, paste. There you go. So z-score is 0.61. That's the answer. We're done. Now let's
so
say,
you put it in directly. You don't have to figure out what 1 minus.
no, yeah, you don't have to. You don't have to. This calculator is very smart, guys. So it does everything for us. Now watch. Let's say a student did not do 1 minus. No problem. Put 0.271. And let's see, guys, if you can figure out a way. It's not going to give you the correct answer, but it's going to give you enough information to know the correct answer. You ready to see what the answer is? What did it give you?
Negative.
Negative, but we know we're on the positive side. So what do you do with this answer? Just get rid of what? The negative sign. Does that make sense? Yeah. So if you get 0.61, you get this one, guys, a negative. Well, we know that you're worried. We need a positive z-score because that's on the right. It's on the right side of 0, guys. This is 0 right here. So it's just switch it, just 0.61. But I prefer that students do it properly. So if you have an area to the right, when you first enter the area, put 1 minus, and then it's just going to give you the answer, guys. It's 0.61. Okay. Let's do one more practice. Now I'm going to take the table. Let's do an area to the left. Okay, let's do this. Okay, I'm going to make the area, guys, 0.43. And I want the z. Okay, 0.43. Let's take you to the table and see how good the table. I'm going to show you the drawback of using the table here. Well, we know the answer is going to be negative. It's a negative z-score. So I'm going to project the z table from the negative side. Remember the area, guys, 0.43. Okay. Do you guys see anywhere where inside the table where the 0.43 is going to pop up toward the bottom, the top, the middle? Where do you see it? 43.
The bottom.
At the bottom. Look, guys. I think this is the closest one to 0.43. See where my finger is pointing at? It's not going to give you the exact answer because you cannot find 0.43. So that will be your best shot here, just to use this. That's the closest that I can get. And can you read, guys, the number for me? So it's going to be negative 0.1 and the second column, which is 8. So it's negative 0.18. That would be a good answer if you use the table, not using technology. But I'm going to show you that the calculator is more accurate than this. Watch. Second, let me clear. Second and distribute. No, inverse norm. Okay, 0.43. 0.1. Watch, guys. Negative 0.176, but if you end up rounding it to 2 decimal places, it will be negative 0.18. But this is more accurate, definitely. So, all right, so this is how we find the z-score if we are given the probability. So don't confuse the two, guys. You have two formulas, and I promise that I won't give you any more formulas in this chapter, just these two. The first one is used to find the probabilities, and the second one is used to find the x or the z value given the probability. So it's just the other way around. We'll do some more applications on this. Okay, exercise 9. Let's do this exercise together. Veterinarian records the weights of cats treated at the clinic. The weights are normally distributed with the mean of 9 pounds and a standard deviation of 2. Find the weight X corresponding to a z-score of 1.96, negative 0.44, and 0. Well, let me write a formula for z, guys, first of all. This is the formula for z. X minus mean divided by standard deviation. Okay, he gives us the z-scores, guys. These are z-scores. He gives us the mean to be 9 pounds. And he gives us the standard deviation. So this is given, this is given, this is given. We need to find x. I'm going to do a little bit of algebra here, guys, to show you how to find x, and I'm going to give you a formula for x. Okay. So let's say the first z is 1.96. Let me put 1.96 there. Equals x, I don't know. He wants the x value. Minus the mean, which is 9, divided by the standard deviation, which is 2. From algebra, guys, do you still remember how would you solve for x? What would you do to solve for x? Any suggestion? If you don't know, that's okay. I'm going to do the algebra with you. No, the answer will be fine if you use the table. That's fine. Somebody is asking me about using the table. Yeah, you can use the table. The system is programmed to accept all answers. Okay, any ideas, guys? How do I solve for x? Forget about statistics. We're just solving for x.
Do you have to multiply both sides by 2 first?
Excellent, excellent. You need to get rid of the 2. So 2 times 1.96. I'm going to show you a shortcut anyway in a second. Equals x. 2 and 2 cancels out, so x minus 9. And now what do I do? One more step, guys, to find x.
You add 9.
Add 9 to both sides. You got it. And your x is 12.92. That's how you find x. But we're going to make matters, just simpler. So I'm going to give you this formula. If I try to solve for x, guys, from this, x turns out to be that z times sigma plus the mean. So use this formula, and let me show you that we could have used this formula to get the 12.92. Let me write them down. When z is 1.96, watch, guys, x equals z is 1.96 times the standard deviation, which is 2 plus 9. Well, if you do the math, guys, it's going to be 12.92. What about when z is negative 0.44? Let me just do it right here. So x will be negative 0.44 times sigma, which is 2, plus 9. Okay, put it in the calculator. Negative 0.44 times the standard deviation plus 9. You can do it all in one shot, guys. 8.12. And when z is 0, what's x? Remember, when z is 0, that means x is the z is the mean. So what is the mean here? It's going to be 9, just be 9. And this is how you switch from z-score to x values. X values is the raw value. Z is a standardized score, but X is the actual value. It's the actual data, X. So sometimes we need to find the actual value.
Professor, so there's going to be three different X values for that question?
Yeah, because you have 3 different Z scores. These are 3 separate questions. This is the first Z, this is the second one, and this is the third one. Just 3 different questions, 3 different answers. Okay. Let me show you guys why this is what you learned now about the inverse norm formula is important. Let me show you this application. Scores for the California Peace Officers Standards and Training Tests are normally distributed. So bell-shaped, they're bell-shaped. We cannot do any work in this chapter, guys, if the data cannot be graphed using a symmetric bell-shaped distribution. If it's not bell-shaped, all of the work that I'm doing here does not apply, will not work. It's all based on the normal curve. We have a mean with a mean of 50 and a standard deviation of 10. So mean is 50 and standard deviation is 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? So to hire people, they have to take this test, which is called the California Peace Officers Standards and Training Test. And if you score in the top 10%, you will be hired. Well, actually, let's say I'm applying for this job and I need to know what top 10% means, what score I need to get. All I know that the average is 50 and I know the standard deviation is what? 10. What would be a top 10% score to qualify a person to be accepted for the job? So we have the probability because it says 10%. Anytime he says percent, guys, that's a probability. We need to find, just the original value, the X value. So let me show you a sketch of what we're looking for and see if you guys can help me figure this out. Okay. This is the mean, watch, 50. Where do you think a top 10%, guys, of people, would they be to the right or to the left?
It'd be to the right.
You guys agree? Because as we move to the right, now scores get higher. Definitely, if the average is 50, the agency is not going to hire someone who plays below average, guys. Then everybody will be higher. It has to be above average. So the top 10% should be shaded to the right. So I'm going to shade a 10% to the right. And let me show you what we're asking for. So you shade here. This is your area. This shaded area is 10%. %10 means 0.110. And look, guys, what he wants. He wants what would be the score of a person here. I need to know what should this person here at the beginning of the top percent score in order to be qualified for the job. Definitely, guys, you agree with me, it has to be above average. When you want top 10% of applicants, it has to be above average score. So that's why we have it on the right. And X, guys, so we need the X value and we have the probability. You learned the formula, which is inverse norm. And who can help me just fill in the blanks here? I need the area to the left. Since the area to the right is 0.10, what would be the area to the left, guys?
0.90.
Yeah, 0.90. This is the area to the left, guys. If this is 10%, this is 90% right here. And then the mean Don't put 0, 1 now because we have X values. We're working with X values. He wants X. That's the difference now. This is 50 and this is 10. And let me show you, you're done. You're just gonna find the answer now. Let's see. Second and distribute. Inverse norm. Put 0.90. Mean is 50 and standard deviation is 10. And you're ready for the answer. It has to be above 50, guys. 62.8. If you want to round it to a nearest whole number, it will be 63. So anyone who scores 63 or higher, guys, will be in the top 10% and will be accepted for the position. Now,
So you always want us to have one decimal place, right?
it depends. He'll tell you. He'll tell you always. And the problem itself will tell you. For example, guys, ACT and SAT scores are not decimals. They're whole numbers. So if they ask you to round it to the nearest whole number, you just say 63. All right. Let me see, guys, make a mistake and don't use 90%, use 10%. I'm going to show you guys what happens, and you have to tell me, guys, one of you should tell me what's wrong with the answer. Watch. Let's say you made a mistake. And that's very, very common mistake, guys. It happens all the time. The students see a 10%, they put 0.1, and then 50 and 10. And then if this is a multiple choice, they're gonna see one of the multiple choice, options as what the calculator displays, and they use it. They think it's correct, but it's not. Watch, there's the answer. I give this question as a multiple choice, and I put 37.18 as a possible choice, and some students selected, but that's a very wrong answer. Why?
It's less than 50%.
It's not less than 50%, less than the average.
Okay, well,
It can't be. How could you be in the top 10% and your score be below average? Average is 50%. Average is right in the middle, at the center. So imagine, guys, someone scored 37 below average and being accepted. That's not realistic. So when you see a low answer like this, you know that your answer is not correct. So you know that something went wrong. Nothing went wrong with 50. The mean is 50. You cannot change it. The standard deviation, guys, is 10. You cannot change it. So the only thing that must have been wrong is this. Well, the teacher says it's always an area to the left. So all you need to do, guys, is just do 1 minus 0.1, and that should give you the answer. Okay. If a student wanted to use z-scores instead of directly doing this, let me show you what else you could have done, but I don't recommend to do that since we're using technology. If you do second and distribute, watch, guys. You put 0.9, this is the correct area, and 0.1 instead. Paste. You get 1.28, but that's a z-score. You can change the 1.28, guys, to an x value, and it's going to give you 62.8. And how do you change it to an x value? Using this formula that I introduced. That's why I introduced the formula for x. You put 1.28 times sigma, which is 10, and then you add 50. Watch. 1.28 times 10 plus 50. You get 62.8, but it's a two-step problem. If you just put the proper input there, you will get the answer right away, which is 62.8. Okay. All right.
can all this be done in the stat crunch?
The inverse norm